Hi listeners, welcome to the video lecture series on power electronics. In the previous lecture, we have seen about various classification of power electronic devices based on their families and based on their controls and requirements. And in this video, we are going to look into a power electronic device called as a power diode, which is an uncontrolled device. Come, let us go into the lecture. In this video, we are going to cover a specific outcome, which is we are able to understand at the end of this lecture, we are able to understand the construction and operating principle of a power diode, and the reference for this above specific outcome is Vimra PS Electronics, Power Electronics, and the corresponding page number is also given for further reading. In the beginning, we will understand what is the difference between a normal signal diode and a power diode, and later we will go into the construction and principle of operation of this power diode. Before going to the lecture, we will understand what is the difference between a signal diode and a power diode. Signal diode is a diode which is generally used in a simple electronic circuitry where the power of the electronic circuit is very less, maybe in terms of few hundred watts. So let us go into the detailed discussion or detailed difference between a signal diode and a power diode. If I look at the voltage withstanding capability or voltage rating of a signal diode, it will be in terms of plus or minus 15 volts, or in the case of the power diode, it will be in terms of kilovolt. In the case of a current carrying capability, the signal diode will be able to carry a current of microamperes to milliamperes, whereas power diode, it could be able to carry a current starting from amperes to kiloamperes. In the case of signal diode, it would be able to carry only microamperes to milliamperes. When I come for the power rating of the signal diode, power rating of the signal diode will vary from milliwatts to watts, whereas the power diode will be capable of handling a power of watts to kilowatts. So if you look at the difference between all these three parameters, power diode is a diode where it could be able to handle huge amount of power, whereas signal diode are used only for very low power applications. If I look at the symbol wise, the power diode and signal diode does not differ anything, both remain same. But in order to make the signal diode to work as a power diode, there should be some constructional difference between these two, and that has been reflected in its structure. If I look at the signal diode is a two-terminal, two-layer device, whereas power diode is a two-terminal, three-layer device. There is an additional layer called as N- layer. Let us go into the discussion of this construction structure, little bit in an elaborated way in the next slide. So if we look at the construction of this power diode, it has two terminals, anode and cathode, and three layers. There is a P plus layer, N- layer, and N plus layer. This plus indicates that it is heavily doped. N indicates that it is lightly doped. Doping means adding impurity to the power semiconductor device. So if you look at the order of doping is 10 to the power of 19 per centimeter cube in the case of P plus and N plus, whereas N minus is 10 to the power of 14 per centimeter cube. And again, if you look at the width of the layer, P plus layer is 10 micrometer in size, whereas the width of the N plus layer is 250 micrometer in size. The N minus width of this N minus layer, it is dependent on the breakdown voltage of the device, or it is dependent on the voltage withstanding capability of the device. The voltage withstanding capability decides this N minus layer width. Before going into the detailed explanation of how this particular structure works, let us go into understanding of a normal signal diode working principle. So now let us take a normal signal diode. The normal signal diode will have two layers with two terminals, anode and cathode. During the forward biased condition in the sense the positive of the input source is connected to anode and negative of the input source is connected to cathode. In this time, the diode will act as a closed switch. It is a normal switch. So the diode current will start conducting. The diode current will flow into it. The source current will flow into the diode. So which means that the diode is in on condition now. How it turns on? Slowly when I increase this input voltage at an voltage called as a threshold voltage, the breakdown occurs and the diode starts conducting. This threshold voltage is dependent on the material in which I use it for fabricating the device. If it is a silicon based device, then the threshold voltage is approximately 0.7 volt. If it is a germanium based device, then the threshold voltage is approximately 0.3 volt, which means the same forward biased condition can be explained with the help of a VI characteristics. Slowly, if I increase the voltage at a particular voltage, say the threshold voltage, the current rises sharply, which means that the diode has started conducting. So this voltage is what you call it as the threshold voltage. This is what I mentioned earlier. 0.3 volt for germanium based device and 0.7 volt for silicon based device. When I increase this voltage at a particular voltage, the diode will enter into its on condition completely, and that voltage at which the diode is completely turned on is what you call it as the threshold voltage. As it was discussed in the previous lectures, that in the case of an ideal switch, once it is behaving as a closed switch, the voltage across the device is 0. But in a practical switch, the voltage across the device is not 0. There will be some voltage across the device even though if it is in on condition. Now in the forward biased condition, the diode is acting as a closed switch, which means that the diode is in on condition. Even though it is in on condition, since it is a practical device, there will be some voltage across the device, and that voltage is what we call it as the forward conduction drop or on state voltage of the device. Now let us look into how a diode works in the reverse bias condition. Reverse bias condition in the sense the negative terminal of the input supply is connected to the anode and positive terminal of the input supply is connected to the cathode. Now the diode is capable of blocking the voltage in the reverse direction. Now slowly if I increase this voltage, even though this diode is capable of blocking the voltage in the reverse bias condition, there will be some amount of current flowing through this device, and this current between this blue line, this black line and this rose color line, this current is what we call it as the leakage current of the device. But when I slowly increase this voltage, at some point the diode will break down and there will be a sharp rise in the current in the negative direction, which means that this is the point where the diode breaks in the negative region. This current, as I told you, this current is what we call it as the reverse leakage or saturation current, and this particular voltage is what we call it as the breakdown voltage of the device. This breakdown voltage of the device is very important since this is the maximum voltage if the diode can withstand during its reverse bias condition. We should be very clear enough that this operating voltage of this diode in the reverse bias condition at any point of time should not be greater than this, which means that the peak inverse voltage of operating device should be always less than the breakdown voltage of the device in order to make the device in safe mode of operation. If this breaks down, diode breaks permanently, which means that it gets damaged permanently. So we have to take care that this VBR should be always seen that the peak inverse voltage of the device should be always less than this VBR. Now this is how a normal signal diode works. Now let us understand how a power diode works. The same reverse bias condition, because I told that reverse bias condition is the condition where the diode will be in blocking state, and we have to take care that the voltage withstanding capability of the device is peak inverse voltage of the device should be much lesser than this VBR in order to make the device to operate in the safe condition. So here, if I look at the structural wise difference, the N minus layer is additional. This N minus in the sense it is lightly doped. So doping is directly proportional to conductivity. Since it is lightly doped, conductivity will also be decreased. So lesser the doping is less because it is negative N minus in the sense it is less doped. So conductivity will also be decreasing, but this conductivity is inversely proportional to depletion width. So if the conductivity reduces, depletion width will increase in depletion width will happen, which means that this width will increase, this width will get increased. So if this width increases, the width of the depletion width is directly proportional to the breakdown voltage. So if this width increases, breakdown voltage also increases. So this is how the voltage withstanding capability of the power diode is being. Now you can see that the voltage withstanding capability of the power device is increased because of this N- junction, N- layer. N- layer is lightly doped. Because of lightly doped, conductivity is also decreased. Conductivity decreases, depletion width increases. Depletion width increases, breakdown voltage of the device also increases. So this is one of the important constructional difference which makes the power diode to withstand higher voltages during its reverse bias condition. So the power diode characteristics are little bit and stretched characteristics when compared with that of the normal signal diodes. So this is what the construction and operating principle of a signal power diode. Now in this video we have seen how the signal diode is different from power diode and how the power diode is capable of handling heavier voltages during its off state and how it can handle huge amount of current during its on state. The one difference between the signal diode and power diode is this power diode has an additional layer called as an N- layer. This layer is responsible for making the power diode to operate at very high voltages and currents. And we have seen the construction wise difference also between these two. In the next video, we will discuss about various parameters of the diode. Thank you for your patience, listening and watching. Thank you.